Alright guys, welcome back to our video. Today is our last video for target 3. So this is the last thing we'll be looking at in this unit. So, the first thing we have is a secant line. A secant line is a line that intersects 2 points on a circle, right? So last time we learned about a tangent line that only touches once. A secant line cuts through, right? So it goes twice. Okay? So that's the definition of a secant line. Then we have the perpendicular bisectors of chords. Okay. And this one goes both ways. If the diameter or radius, it doesn't matter which it is, but if it goes to the center point, right, and intersects a chord, right, so I have my diameter and radius here, and my chord here, right, then, so if it bisects it, then they're also perpendicular. Right? So if you have a bisector, so if these are equal, then it's also a right angle, right? Perpendicular is a right angle. Where bisect, right, means it creates 2 congruences. Right? It also works the other way. If, right, you know it's a right angle, then you also know that those things are congruent. So if you know one, you know the other. Doesn't matter which one you're given. So let's look at our last page of notes. So we're going to flip the page. All right. So we're going to look at 2 examples with angles, and then we're going to look at our perpendicular bisectors. Okay. So looking at example 9 is find the missing angle. If you look here, I have 2 chords. So the first thing we're going to talk about is one theorem we have for finding an angle when 2 chords intersect. And really, this angle here, right, or this angle here, they're the same because those are vertical angles, is really the average of the other 2, right? So x equals, right, and I'm going to just write a generic, the big arc plus the small arc divided by 2. Alright, so x equals the big arc plus the small arc divided by 2. That's with 2 chords. So here I have 175 plus 55 over 2, which equals 175 plus 55 is 230 over 2, so it equals 115 degrees. Okay. And so it doesn't matter which angle you're finding because those are the same. Okay. So it's really just an average. You add them up and divide by 2. For your secant, right, so over here, now I don't have 2 chords, I have 2 secants because they meet at a point outside the circle. They don't stop, right? They don't cross in the circle. They meet at a point outside the circle. So these are actually called secant lines. Right, if I want to find this angle, it's similar to what we just did here in example 9, just one small difference. Right, the secant line x equals the big arc minus the small arc divided by 2. So x equals the big arc minus the small arc divided by 2. So that's 140 minus 50 over 2, which is 90 over 2, which equals 45. So those are very similar if they cross inside or they cross outside. Right? So this one's crossing inside the circle, crossing outside the circle. Alright, then looking at 11 and 12, this has to do with our perpendicular bisectors. Okay? So looking at example 11, circle O has a radius of 5. Right, so that's told to us here. And CE equals 2. Diameter AC is perpendicular to chord BD at E. Right, so that tells us, right, AC is perpendicular to BD that tells me this is a right angle. It wants to know what the length of BE is. So we're finding this whole thing. Okay? Well, one thing I know, since these are perpendicular, right, these two sides are congruent. So I only have to look at one side of this. So I'm going to look over here, right, and if you look at only one side, then, right, it's a right triangle. So I'm going to look back at the first thing it told me. The radius is 5, so this whole thing is 5. Well, if this part's 2, then this part has to be 3. Now I can use Pythagorean's theorem to find x. Okay? So 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. X squared equals 16. So x equals 4. Okay? Well, if I'm finding the total length of BD, if this is 4 and this is 4, right, then that total length, this total length here equals 4 plus 4, which is 8. Okay, so sometimes you have to double that number or cut it in half so that you can use it. All right, let's look at example 12. Diameter AB bisects chord CD. Remember, bisecting means it cuts it in half. So AB bisects chord CD. Okay. So that means, right, if AB and CD, those two sides are congruent. So then it tells me AE equals 2. Right? So this length here is 2. FD is 17. FD is 17. What is the length of CE? So it's asking me for the length of CE. So I'm just looking for this. Well, one other thing. Since AD bisects chord CD using our theorem, it also means this is a right angle. Okay, it bisects that. So all I'm going to do in order to solve this is create a right triangle. I'm going to connect C and F. Right? Sometimes you'll have to draw in lines that you don't have. Well, CF is a radius, just like FD is a radius. So that's 17. If you look, AF is a radius as well. It's also 17, right, from here to here. This part's 2, then this part's 15. Now I can use my Pythagorean theorem. X squared plus 15 squared equals 17 squared. So x squared plus 225 equals 289. And so then x squared equals 64, taking the square root, and the square root, x equals 8. And that's all we're looking for. It only asks for CE. It didn't ask for the whole length of CD, like the other one did. Okay? So then we're done. Okay? So a lot of these problems have a lot of inner working. You just kind of got to figure out, okay, what's it giving me and what am I looking for? And a large part of it is knowing the radius pops up in a whole bunch of different places within your problem. All right, that's all we have today. I'll see you guys tomorrow.